Welcome to clickmyproject.com. Our product title is Nonlinear Control of Single Base PWM Rectifiers with Inherent Current Limiting Capability. Now we are going to discuss about our product abstracts. In our process, the single base full bridge rectifiers in the investigated under the nonlinear controller to achieve the accurate DC output voltage regulations. We are giving the process input for the AC voltage and get the unity power factor operations and closed loop stability with the limited input current. The delivered operation of the process, the current limiting nonlinear control is fully independent of the system parameters, has a simple structure of the leads and easy implementations and achieve the PFC of the input of the rectifiers. The rectifier process the practically corresponding to PFC for the complete system. Using the nonlinear process, the control operations to investigate the based on the input to state stability. The closed loop system stability in this sense of the boundary lines of the evenly converge of the desired solutions of the given RMS values. The consider a single phase full bridge rectifiers feeding the resistive process. The controller under the converter process consists the boosting a filtering inductor, the parameters of resistance and DC capacitors, the four switches connecting the signal to obtain the PWM circuits. This filters can be different type of the to achieve the better harmonic grid current. The L filter of the consider the simplicity since the explain the process, the stage of the current limiting process. In the process, although we get the process section in the main propagation of the paper process, the alternate of the closed loop system stability is analytic framework of the selection controlled parameters, and then the voltage additions PLL are the needed of the further control is implementation. The current limiting capability of the guarantees even in the case of the input voltage verifications. The extensive experimental results are provided on the single phase full bridge rectifiers. The proposed approach the verify the current limiting capability. After the DC voltage, we get the output of the DC voltage and the give input AC voltage process. Now we are going to discuss about our product flow diagrams. In our process, we are giving the source AC voltage. We give some voltage AC power. We get the using the full bridge rectifiers. The rectifier means we convert the AC to DC. We have using the full bridge rectifier. The type of the bridge rectifiers, the half wave rectifiers, full wave rectifier, and bridge rectifiers. The bridge rectifier is purely get the AC to DC. So we are using the rectifiers of the bridge rectifiers. After we are going to that conversion process, the converter process, the AC to DC converter process. At the same time, we are using the controllers for the PWM. The PWM controllers, we get the output from the current source, and then we get the converting process. We give the PID controllers from the PWMs. After we get the result of the low pass filters, so we get the some process output. We are going to the filtering the process. Filtering the process, we are using the low pass filters. Is the we have constant value we fix it. After we get the value of the process PID controllers, and then same time the PWM controller. The both the controllers we get the one process of the output. We get the filtering process. After we going to the through the output process, we are connected to the load some any purpose of the week using the load functions. So our main objective for this flow, we are giving the AC voltage input and we get the DC voltage output. Now we are going to discuss about our product running procedure. We have using the software for the MATLAB 2013 version, and we have using the tool for the simulating tool. So I have designed the tool in the simulating tool. Is using the simulating tool, I have designed the main process. After we getting the each components from here, the simulating tool for what are the components we are getting from the each and every libraries from here, the simulate library. After we finish the designing the process, we are getting going to the running procedure. So this is the main our product design. So I have hide the process. This is the input for process for the AC voltage, and then using the rectifier mode process. The rectifier we are using the rectifiers. In this rectifiers we have AC to DC conversion process. From the rectifier full way rectifiers using the maximum performance of the accurate the convert to the AC to DC converters. After that we are using the low pass filters. AC to DC conversions we have some occurred in the AC voltage in the previous output, so we are filtering process using after we get the purely the DC voltages. And then mainly we are using the controllers. We are using the two type of controllers, PID controllers and the PWM controllers. Both combination of controllers we are using the, and then we set the threshold and constant values. The PID and PWM controllers we get the output result to the DC voltages. I'm going to show the input and output voltages waveforms. This is the input for the AC voltages. This is the input voltage for the 100 voltages AC voltages, and the current flow for this block for the, this is the current flow for the our product designs. After we get the output for the DC voltage in our process. We have designed this process. Mainly we are full bridge rectifiers after controllers and the input output functions. So thank you viewing our product website.